Hello, in this video, we're going to work with an actual data set, and we're going to learn how to extract statistics like mean, median, and mode from that data set. Now, on the Canvas page, if you can go ahead and go to our homepage and scroll down to week 3. Under the class notes part of week 3, you should see some videos and some PowerPoint presentation, and then you're going to see some spreadsheets. They're both called CARS Lab Spreadsheet. What I want you to do is download one of these files. Now, if you have Microsoft Excel, you can download the Excel file. If you don't have Microsoft Excel on your computer, you can download the CSV file. So I'm going to download the CSV file. So I'm just going to click on that. And at the top, it says download cars93.csv. I want you to download this. And after you download it, put the file on the desktop of your computer so it's easy to find, okay? Next, I want you to open a new tab and go to Google and Google Sheets. The first thing that should show up is Google Sheets, which is a spreadsheet. Let's click on that. And then you're going to want to sign in. If you have a Gmail account, you should be able to sign in with your Gmail account or just create a Gmail account real quick. And then the next thing you want to do is click on blank spreadsheet. So I'm going to click on that. It's in the top left-hand corner. Okay, now we have a blank spreadsheet. Now remember that I told you to put that CARS93 file on your desktop. The next thing I want you to do is go to File and click on Import. Okay, you'll see a bunch of stuff up here. My Drive shared with me recent upload. Go to Upload and take that file, that CSV file or the Excel file, and drag it and put it into your spreadsheet. Okay, when you do that, it's going to ask you, do you want to import the data? And you're going to just say, yep, I want to import it. Okay, and now you should have all of that data in the spreadsheet on Google Sheets. Okay, so let me tell you a little bit about this data. This data is from 1993. It was a sample of 54 new cars, and new being at the time in 1993. So what we have is for these cars, we have type. This is a variable, tells us that we have 54 cars and we either have a small type of car, a mid-size, or large. You can see that in the column. Then we have price, which is in thousands of dollars. We have one car, so this row 2, is one observation in the sample. And this particular car was a small type of car. It was $15,900 to purchase. The miles per gallon in the city was 25. The drivetrain means it was front wheel drive. The number of passengers it could hold was 5, and the weight of the car was 2,705 pounds. So weight, this variable is in pounds, and this price, this variable here, is in thousands of dollars. Okay, and you can see that if you scroll down, you can see it's a bunch of data, and it goes all the way down to 55. There are 54 observations. The reason it goes all the way to 55 is because our first row is describing the variables. So there's 54 cars. And so we want to analyze this data. First thing I want to know, let's focus on the weight variable. Is this variable categorical or is it numerical? Well, it's a numerical variable because you can see the numbers here and you can add weights together and you could average them. So it's numerical. Is the variable continuous or is it discrete? Now, weight is something that we measure. So it is a continuous variable. However, they have rounded it to discrete numbers, okay? But weight itself is continuous. It's just been rounded. Something like passengers. Passengers is also a numerical variable, but it's discrete. This variable type, whether the car is small, mid-size, large, is a categorical variable, right? And I think it's also ordinal. If you take a look, it makes sense to order um, the different answers here, like small is before mid-size, which is before large. So I would say this is an ordinal variable. And price, and just really quickly, price, miles per gallon, those are numerical. And drivetrain, well, that is categorical. Okay, let's focus on the miles per gallon. So what I'm going to do is I am going to right click and I'm going to copy all of this data. So you can see that when I highlighted it, it highlights the whole column. And I want to extract this particular variable from the rest of the data. So what I'm going to do at the bottom of my screen is there's a little plus sign at the very bottom left-hand corner. And I'm going to create a new sheet. And then I'm going to click on column A, and I'm going to right click and I'm going to hit paste. And the reason I'm doing this is because when I play with this variable, I don't want to make any mistakes that could affect the other variable. So I'm putting it on a separate sheet so that I don't mess up the original data. Okay, what I want to do is off to the side in cell C2, notice that on the top I have the letter C, and on the left the number 2 is highlighted. This is cell C2, and I'm just going to type mean, median, and mode. Okay, I've typed those 3 things in, mean, median, mode. So you may want to do that as well. And then I'm going to move to the right to D2. Let me zoom in a little bit because we're going to enter a formula. So I want to find the mean, median, and mode of this data. And I don't want to do it by hand. I want the computer to do it for me because there's just a lot of data. So let me go back to the top. I'm going to tell you the formula. Now remember that mean is also known as the average. So the formula here is whenever you want to use a formula, you have to type an equal sign. So type an equal sign and then type the word average, okay? And you're going to see some things pop up. And what's popping up is the computer's trying to figure out what formula you want to use. And we're going to try to use the first one. So we're going to type equals average, and then you're going to do Shift 9 to make a parenthesis. So you're going to make that parenthesis. And now you're going to click on the data that you want to average. Let me zoom out a little bit. My first piece of data starts here on A2. And you can see when I clicked on that, it says A2. I'm going to go to A2 and I'm going to click on it and I'm going to drag it without releasing my cursor. I'm going to drag all the way to the bottom of the data set, all the way to 55. And if you go a little bit too far, just hit escape and try again. So I went too far, so let me try again. I'm going to say equals average, parenthesis, click on A2, and I'm going to go all the way down to A55. Okay, stop. And then I'm going to let go, and you can see up here, it says A2 colon A55. Then I'm going to put an in parenthesis. Let me zoom in. So this is telling me the range. It's saying start at A2, end at A55. If this gives you trouble, like dragging, you can just type that in. Start at A2, end at A55. And you're going to use a capital A and a capital A here. Depending on the data set, you may have, if you try to do this with a different data set, you may have to go further than A55. So just keep that in mind. I'm going to hit enter. Okay, oops. So we can see that the mean is about 23.3. Now I'm going to go to the median. I'm going to type equals median parenthesis. Now we could do the drag and drop, and look, the computer already knows. If you look to the left, they're telling you, oh, do you want to find the median of this data? And that is what we want to take. So if you just hit the right arrow, oops, or just hit enter. I think if you just hit enter, it will calculate what it's trying to fill in. But let's say it's trying to put in the wrong data or something. You just say A2, like type A2 colon A55, hit enter. And we got that the median is 21. Now for the mode, I'm going to hit equals mode. And then I'm going to say, see, this time it didn't show up. I'm going to say A2 colon A55. If I just did 5, you can see it stops here at 5. If I made it a 6, it would stop at 6. But I want it to go all the way to 55. And I'm going to hit parenthesis, enter. So now we have the mean median mode. You know what? I want to bold this. So there's a little bold here. Now we have found 3 statistics. The next thing I want to do is just kind of take a look at what I see. I see that the mean is bigger than the median, which is bigger than the mode. So I see that the mode is smaller than the median, which is smaller than the mean. If you remember from the PowerPoint presentation, we said that if we have this situation where the mean is to the right of the median, that means that probably the data is skewed, and it's right skewed, meaning that it has a tail to the right, because this happens with skewed data. Let's see if this data is skewed. So I'm going to highlight this column, and I'm going to go to Insert, and then to Chart. And it'll give me a histogram of this data. Remember, we said a histogram is just a bar chart for numerical data. And you can see that what it's telling you, and the bins here, so it looks like the bins have a width of 5. So the lowest number they're using is 15 and going to 20. And they say, if you look in this data and you count how many numbers are between 15 and 20, there will be 20 numbers. And then if you count how many numbers in this data set are between 20 and 25, you'll get a little bit over 15. It looks like it's 16. And between 25 and 30, it looks like it's 11, and so on. But we can see that this graph has a little bit of a right tail. So it did turn out that it was right skewed. So this is the frequency, how many times so the y-axis is the frequency, how many times a particular number showed up. And we see that anything between 50 and 20, the numbers between 50 and 20 showed up about 20 times. Now, just in case you get a different type of chart, let's say when you hit chart, it gave you something strange like this. What you can do is go to the right, you're going to see chart editor, and you're going to click on the chart type, and you're going to see histogram. And that way you can get this histogram that I just created. And you can rename this. You can call it histogram of miles per gallon of the city, or you can name it whatever you want. You can type here. Okay, great. So we have made our first histogram. The next thing I want to do is down here, I'm going to type minimum, maximum. I'm going to type range. And let's also do standard deviation. And I want to make this column a little bigger. If you double click right here between C and D, it will extend itself so that the words aren't running into another cell. I want to figure out, instead of sorting this data by hand, I would like the computer to tell me what is the smallest number in this data set and what is the largest number. So to find the minimum, I'm going to enter into this cell. Let me zoom in a little bit. I'm going to say equals, and I'm going to type min, okay? And then we're going to choose that same data, A2 to A55, okay? Because I zoomed in, it kind of did something wonky here. So let me go back and zoom out. Okay, here we are. So you can see it says A2 to A55. And the min is telling the computer to return the minimum value. And so the minimum is 16. Let's find the maximum. We're going to type equals max, and then we're going to say A2 to A55. If it shows up, just hit enter. If it doesn't, you want to type A2 with a colon A55, and we'll get 46. Now let's find the range. Unfortunately, the program doesn't have a quick way to do range. But if we just think about it a little bit, the range is the difference between the maximum and the minimum value. So whenever we do a formula, we hit equals. So I'm going to say equals. I'm going to click on the maximum value, this 46. And you can see that it shows up. It says, oh, do you want this cell D7? And then I'm going to say, yeah, I want that. And I want to subtract and put the minus sign, this minimum here. So this cell is D6. So I'm telling the computer, I want you to take 46 and subtract 16 and return that. And if you hit enter, it'll give you 30. And you could just also do that with a calculator if you prefer. Okay. So the next thing I want to do is find the standard deviation. Now we said the standard deviation describes how far away the data is from the mean. So let's look over at this histogram. The mean is 23.3, which in terms of these columns is in the second column between 20 and 25. That's where the mean lives. Okay. And you can see that we have a lot of data to the right that's far away from the mean. There's some numbers that are far away. So let's see what kind of number this returns. The formula that we're going to type into the cell is equals. You're going to do ST. You can see already, they say standard deviation, STDEV. But before you hit enter, I want you to do a dot S. You're going to see that they're giving you two different things. They're doing dot P and dot S. The reason for this is the formula for the standard deviation for a population is different than the standard deviation of a sample. We'll talk about this a little bit later, but right now, I want you to do dot S because this is a sample of cars, a sample of new cars. It's not all new cars in 1993. So you're going to do STDEV dot S. And then we're going to do parentheses. And let's see, it was A2. That's where we started, and we end at A55. Okay, we're going to close that parentheses, and we get this number 6.624. So you can see that number is a bit a ways from 0, and that's because of these values that are far away from the mean. You can see that number 46 is a bit far from the mean. And I want to bold these. Okay. Great. So now we've learned how to calculate the mean, median, and mode, the range, the standard deviation for a variable. Let's go back to our original data over here at CARS 93. Now, something you can do if you're curious is you can copy, let's say, the price. You could copy that one and put it in a new sheet and do the same thing, the mean, median, and mode, and try to figure out if you have left skewed, right skewed data, or you could do it for the weight as well. I want to do it one more time though, but for categorical data. So what I'm going to do is I'm going to copy. So I'm going to right click, let's say this first column here. I'm just going to hit copy. And I'm going to pull up a new sheet. So remember in the bottom left-hand corner, there's a plus sign. Got a new sheet. And now I'm going to paste this into the first column. Okay. This type, I'm going to bold that because that's actually not part of the data. So I just don't want it to get confusing. So this is the data. It starts in cell A2. And just like before, it ends in A55 because we had 55 pieces of data. Now remember, this is categorical data. So if we try to do something like, if we tried to find the mean, so let me just type mean. The formula that we use equals average won't work here. Let me just try to average the first few. I'm going to give you some kind of error because we can't add words and divide by the total. That doesn't make any sense. We cannot find the mean for this data. We can find the mode, and we can also find the median because this data is ordinal. So what I'm going to do is I am going to make a bar chart. So I'm going to click on this data, this variable here, so column A, and then I'm going to say insert chart. Now, it gave me a pie chart. I don't like that. I want to work with a bar chart. So I'm going to go over to the right, and I'm going to switch to, they say histogram. That's not, histograms for numerical data. I'm going to go over here to count type. And if you get the wrong one, just try to switch to different, like choosing different types of charts. And now we can see, and they even put the bars in order for us. We have, and let's call this type of car. And we can see that small, the word small appears, looks like a 21 times. If I zoom in, you can see it's just above this 20 here. And mid-size appears, it looks like 22 times, and large appears about 11 times in this, this data. So the mode for us is the mid-size. Remember, the mode is the tallest bar. So we can't find the mean, but let's put mode here. The mode we can see from the histogram is mid-size. And what about the median? Well, we did this in the video, but let me remind you. We have 21 small, and it looks like we have 22 mid-size, and we have 11 large, and altogether there are 54 cars. So what did we say we do to find the middle? We said we take how many data values we have, add 1 to it, and then divide by 2. So 54 plus 1 is 55. And so if we did 55 divided by 2, we would take the 27th, the whatever's between the 27th and the 28th data value. So what I can do is I know that small appears 21 times, followed by 22 mid-size. So if I was to list them all out, I'd have small, 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 and so on, and I'd have that 21 times, followed by 22 mid-size. 27.5 is bigger than 21, and it's somewhere between, if 22 mid-size, if I add 21 and 22, I would get 43. So this 27.5 is somewhere in mid-size. So the median is going to be mid-size. I think it makes more sense to think about this. I'm going to have small repeated 21 times. So this will be let's just say we did this a bunch of times. Way down here somewhere, this would be the last small, let's say, and this is the 21st small. Then we'd have mid-size, which would be the 22nd, then mid-size. And this would continue. We keep typing mid-size until we get to 43rd. And how I know that is because I'm taking 21 and adding 22 to it. And so by doing that, I know that the 27th one is somewhere between 21 and 43. And all of those between 21 and 43 are mid-size. So it has to be mid-size. I hope that makes sense. It's not that big of a deal if you don't understand that so much, but you can find the median. Now, we cannot find the mean here. All right, let's go back to the original data set. So down here where it says cars 93, I'm going to click on that. The last thing I want to do is make a scatter plot. So I'm going to click on, let's see, maybe let's make a scatter plot where we compare the miles per gallon in the city to the weight. Now, this is obviously an observational study, right? We just have 53 cars and we are seeing how many miles per gallon they get and the weight of the car, right? We're not influencing the miles per gallon and we're not influencing the weight. We were just observing data and writing it down. So this is an observational study, which means that we can't show through an observational study whether one variable affects the other, but we can see if they're linked. So suppose we think, I would think that the weight of the car would affect the miles per gallon in the city. Now, I can't prove it, but I would think that the weight would affect the miles per gallon. And so that means the explanatory variable. And I'm just writing, you don't have to write this. I just writing it, just thinking aloud here. And this is also a review of things that we've covered in this class. The explanatory variable would be the weight, and the response variable would be the miles per gallon in the city. Now, if I was to make a scatter plot, I think what I'm going to get is a negative association, because I think when weight increases, the miles per gallon goes down. So they're going to be opposite, going in opposite directions. So let's see. I'm going to click on weight, and I need to click on miles per gallon in the city as well. So it depends on what you're using. I'm using a Mac, and I'm going to click on Command. And I'm going to hold the Command button down. That way I can highlight two columns. If you're using a different type of computer, you may have to investigate and Google how can I click on two things or two columns at once. It may be Control, but I think it's Command for most computers. And now you can let go of the Command key and you're going to go to Insert, and we're going to go to a chart again. So click on Chart, and this will give you a scatter plot. If it didn't for some reason, you're just going to go to this chart type and choose scatter plot. And I see it looks like a negative association. It looks kind of like things are going down from the left to the right. So I was correct about there being like a negative association. Okay, I have the miles per gallon on the bottom, and I have the weight on the vertical axis. And I believe we said in a video, the explanatory variable should go on the x-axis and the response should go on the y-axis. So what I'm going to do over here in the chart editor is asking me, you see where it says x-axis? It says, what do you want the x-axis to be? I'm going to switch that to weight, and I'm going to switch the y-axis, which is this series here. I'm going to switch it to miles per gallon. Oops, let me go back. All right. Maybe, nope, don't do that. Okay, well, there's some way to switch them. I don't want to waste too much time, but even if you switch them, the graph should look similar. And in fact, oh, I see, they did switch them. So this does say, these are the weights, it's just the wrong name. This should say weight. And this one should say miles per gallon. I think I just don't know what happened there. Over here it says horizontal axis. You should be able to, you could play with it, but I wanted the miles per, and you can see that the miles per gallon because of the numbers here, and the numbers here. So there is definitely a negative association. Let me make this a little bit smaller, and let's do one more scatter plot. Let's see the relationship between the price and the weight. And so I'm going to hit Command. I'm going to click on price, and then I'm going to click on weight. Okay, I would think that more a car weighs, it's probably going to relate to a higher price. Okay, so let me write that off to the side. I would think the weight of a car would result in a higher price. So again, I would think the weight of the car is the explanatory variable and the response would be the price. Now, what kind of association do I expect? I would expect a positive association. I think the heavier the car when it goes up, the higher the price. So let's see if that works. I'm going to click on weight and hit Command, click on price, and then I'm going to insert a new chart. And it looks like it put price on the bottom. That's okay. We can definitely see a positive association between these two. And we can try to switch the x-axis to weight and then the other one to price. And all we have to do is just change the axes here. And you can see the higher the weight, the more expensive the car is. It's going up. Okay, so I think that's enough for today. So we've learned how to extract some important statistics from a data set and to make scatter plots and histograms. On the test, I may ask you to do something like this. I've given you a homework where I have another example and a data set, and I ask you to find some information from the data set so you can have some practice before the test.